Okay, so here we are in 6.1. This will be the first video in a new chapter. Different color background there, went to green. Alright, this first section, 6.1, is about parabolas. And the function of a parabola looks like this. ax squared plus bx plus c, where a, the number in front of the x squared, is not equal to 0, because then that would go away and turn it into just a linear equation. Alright, so there's the format for a parabola, and we're going to do some different things with it. We're going to refer to my page right here off and on as we start discussing this. And first of all, we need to talk about some vocabulary. So let me just real slowly start introducing you to things. So here on the right or left is a parabola, and I'm just going to go over a few things at a time. We have, first of all, a point here called the focus, and we also have a line here. In this particular one, it's horizontal, and down here it's vertical. Okay, and it is called the directrix. Okay, don't worry about any of this other stuff at this point. It's got the focus right here, which is one point, and you have the directrix. And one of the things that a parabola has, as far as the definition, it's the set of all points. This red line is the set of all points in a plane equidistant from a fixed line, the directrix, and a fixed point not on the line, the focus. So if you take a line and draw it from here to anywhere on this parabola, and then draw a line from the parabola perpendicular to the directrix, those distances will be the same. Okay, so it's equidistant from here, this point right here, and from the directrix when you go perpendicular to it. And I don't know if the definition says perpendicular. It doesn't look like it. So anyway, that's what we've got here as far as what the focus is and what the directrix is. Okay, we also have an axis of symmetry, and the axis of symmetry goes through the vertex, which is the lowest point or the highest point or the point furthest to the left or right of the parabola. So the vertex is here, and there is a line that goes through the focus, through the vertex, called the axis of symmetry. Alright, so what I'm going to do here is I'm going to call this point here F, focus. I'm going to call this point here P, and I'm going to call this point here G. Alright, so the distance from F to P and from P to G are the same. So PF equals PG. Okay? Now, if you used your distance formula, you can come up with a standard equation of a parabola. I'm not going to go through all of the hows. If you look in the middle of page 527, you can get an idea of how they get this formula. But the formula of a parabola looks like this. So this is important to write down. Okay, x squared equals 4py. Alright. Okay, so made a little change here, but just want to talk about what this p value is. You know what x is, you know what y is. You know, it's left or right or up or down. But p is going to be the distance from the vertex to the directrix. Okay, this distance right here. It's also this distance right here. That's also p. Okay, so when we're looking at the distance from here to here, and this opens up, notice my p is positive here, and down here, from here to here, we're below the x-axis, so my p is negative. So basically, y equals negative p. This distance here down is y. We're going down, and it's negative. So to our directrix, y is negative p. Okay, and when that is the case, we have this formula right here. When x is negative, we have a formula that's a little bit different, and it's going to be y squared equals 4px. When you have your exponent of 2 on the x, it's going to look like this, or it could be upside down. When you have the square or the exponent on the y, it's going to open sideways from left to right. And when that happens, your x is the negative p rather than the y. Because see here, you're at the origin and you're going over negative to get here to the directrix, so it's negative. And then the distance from here to your focus will be your positive p. And then your x and the y kind of stay where they're at. Alright, so let's look at an example here and just get some practice kind of figuring out a little bit more about what's going on. I'll leave those two formulas there. And the first example says find the focus and the directrix of the parabola y equals negative 1/12 x squared. Alright, so we've got the x squared, so we know that it's going to open up or down. Doesn't really matter at this point because they're not asking us to graph it, but at least we know that it's going to be this first equation that we're going to do. So what we're going to do is we've got it written this way, and we're going to have to put it in this form so we can find the directrix as well as the focus. So all we're going to do is rewrite this a little bit differently. Okay, so I'm just going to flip this around. No particular reason, except I just like having the format the same, the x on the left side. Multiply the entire thing by 12 to get rid of our fraction. So that gives me, in fact, let's multiply it by negative 12. So that gets rid of my negative sign, so that gives me x squared equals negative 12y. Fraction is gone. Alright, so what is the difference between what this looks like and this here? This is 4 times something times y. This is negative 12 times y. So we have to write this as 4 times something times y. And that something, then, we can just change it to a negative 3. So 4 times negative 3 gives me my negative 12. So now it's in standard form. Okay, I've got my 4, my p, which is negative 3, my y, and my x squared. So that's good. So my directrix, we said earlier, when we have it in this format right here, my focus is going to be 0p, and my directrix then is going to be y equals negative p. So now I have to do is figure out what my p is. Well, my p is right there, and it is that negative 3. So my focus is going to be 0, negative 3, and my directrix is going to be negative, from this negative right here, negative, a negative 3, which is going to be positive 3. Okay, and if I were to graph this, okay, so there's my focus, my directrix. Let's kind of get some stuff out of the way so we can show what this would look like graphed. Alright, so that's going to be there. Okay, so I have this, and my focus is at 0, negative 3. Okay, my directrix is going to be at positive 3, and that would be 1, 2, 3. Positive 3. It would not be 3 above this, because that would be at 0. It would be at positive 3. that being the case, my directrix is never within my parabola. So I know it can't open this way because it puts my directrix inside. So it has to open this way. Okay, and notice my focus is 3 away from my vertex, and my directrix is 3 away from my directrix, or from my vertex. So my directrix is 3 above, and my focus is 3 below, just like that. Okay. So let's look at example 2. Now there's my two formulas there. It says find an equation of the parabola. So we're going to look for an equation like that, in one of those two forms. With the vertex at 0, 0, so at the origin, and the focus at 5, 0. Then graph. Alright, so let's get started. First question you want to ask yourself is, where is the focus? And we can tell by looking at this here. If we were to graph the focus, it would be at 1, 2, 3, 4, 5, right there. Whenever the focus is on the x-axis, or whenever there's a number in the x position here, then your parabola will open this way, because it wraps itself around the focus. Whenever the focus opens up or down, it's when the y value has a number, because then the focus would be up here, and then it would wrap around this way. Okay? So, if there's a number in the x position, it opens left to right. If there's a number in the y position, it opens up or down. So because this is in the x position, we know it's going to be opening left to right. And whenever anything opens from left to right, we use this formula right here. And up and down is this formula here. Okay, so it's just keeping track of that, writing that down in your notes so that you remember what it's going to do. Alright, so what is P? P is always going to be this number right there. Okay, in the focus, it's going to be that distance from the vertex. The vertex is at 0, 0, focus is at 5, 0, so therefore the P is going to be this number here. So the equation is going to be, using that, y squared equals 4px, and let's put some numbers in here. Y squared equals 4, what did we say the P was? It's 5. Or y squared equals 20x. There is your formula. So you can leave it this way or leave it this way. Okay, now they want you to graph it. Well, we already put the focus on here. We know the vertex is at 0, 0. So pretty much all we're going to do is we just know that it opens this way. So really the only thing the focus did was told us it was going to go this way instead of this way. Okay, and that's it for example 2. Now what we're going to do is we're going to move this parabola away from always having the vertex at the origin. We're going to shift it around a little bit. So we're going to come up with the same formula to solve it, but we're just going to add a little bit more to it. So let me clear this up, and we'll start this on the next video.